All right, thanks everyone. It's a real pleasure to be here. I think I presented at one of these 8 or 9 years ago when I was finishing up my PhD in the Otways, so it's really nice to be back working here and back at this forum, which is always great. So I am part of the Flare Wildfire Research Group at the University of Melbourne, based at the Creswick campus on Dja Dja Wurrung country. So I pay my respects to traditional owners and elders past and present of all the lands that I work on, which includes most of Victoria for this project. So this work is only made possible with a huge team. So this work's undertaken by University of Melbourne and Museums Victoria, and the funding comes from DECA and Natural Hazards Research Australia. So we know fire is a ubiquitous disturbance, and it's also been pivotal to the evolution of life on Earth. But we're moving into a really scary fire future. So whichever climate scenario you look at, fire regimes are going to change. And this is coming at a time that there's increasing awareness of the role of fire in supporting healthy ecosystems, but there's also increasing controversy about the way we use fire. And the implications of fire regimes for biodiversity and fire risk. So in the face of these uncertainties, it's really critical that we have good empirical evidence and timely field data about the effects and the effectiveness of fire. So about 5 years ago, the Department of Environment, Energy and Climate Action, DELP at the time, embarked on a really ambitious statewide research and monitoring program looking at the effects of fire on ecosystem resilience, and my team has been involved in implementing this program alongside other universities. So there's three broad objectives that are up on the screen there. So I guess the first one is what they're trying to do is trying to understand trying to test some of the underlying assumptions about ecological fire management. So things like tolerable fire intervals and fire response curves, trying to get a better understanding of some of these underlying paradigms in fire management. And also sort of updating our existing models and trying to get really good baseline information about how species respond to fire in different ecosystems and how we can subsequently manage them. So this has resulted in a network of more than 1,600 research sites that my team's been involved in across 9 major ecosystems in the state. We're collecting data on mammals, birds, floristics and vegetation structure. So it's a space for time substitution, so we're looking at the effect of fire over the long term by having sites of different fire ages, so recently burnt sites to really long unburnt sites and everything in between. So we're working in a range of different systems. So we've got arid systems up in the Mallee, all through the forested systems to heathlands, and all the way up to subalpine woodlands. And the two main things we're looking at are time since the last fire and the intervals between fires. There are two main variables. And the work we're doing in the Otways is focused on this vegetation type, so tall mixed forest. So which is actually neither very tall or very mixed. So it's commonly dominated by messmate stringy bark and occasionally peppermints. In this part of the world, it co-occurs with heathland, so it occurs in the Anglesea area and in the Carlisle area. So there's a fair bit of overlap with the foothill forests that Claire was talking about before, but it's not quite the same. Sort of lower elevation forests, fairly scrubby forests. So it occurs on in the areas near the heaths. It occurs on areas that have deeper soils. It's got a fairly diverse understory. Can be grassy, can be brackeny, but sometimes quite a few different serotinous shrubs as well. So this is our study area in the Otways. So the areas coloured red through to yellow are different growth stages in this vegetation type. The grey is just other vegetation types. We don't care about those at the moment. So as I was saying, it occurs in the Anglesea area and up in the Carlisle area. So we've got about 100 sites in the Otways as part of this project, and the rest of the sites so the other 100 sites are in East Gippsland, Central and East Gippsland. But I'll be focusing on the results from the Otways today. So we used about 30 sites over in the Eastern Otways that that were set up as part of Melbourne Uni's long-term project in the Otways that was part of my PhD almost 15 years ago. And the rest of the sites are all new sites in the west. These graphs here are just showing the spread of the two different variables that we're looking at. So on the left here, we've got the time since fire. So a range of sites across that time since fire spectrum, a few gaps, because that's just what we're dealing with. Lots of recently burnt sites and lots of older sites. So one thing to note about the Otways, though, most of the recently burnt, or pretty much all of the recently burnt sites have all come from prescribed fire, which is different to the sites in Gippsland, which were affected by recent fires, especially the Black Summer fires. And we were able to get a range of fire intervals, from really short fire intervals at our sites to really long fire intervals, mostly focusing on the recently burnt sites. We focused on 4 main components of biodiversity. So we use predefined protocols that are used statewide. So point counts for birds, cameras for mammals, quadrats for floristics, and measuring structure as well. And I'm going to focus mainly on the fauna results today, but here's just one example of the sort of insights we can get about how these ecosystems work and how they respond to fire. There's been a lot of recent ideas about how understory and shrub regeneration occurs and how it affects flammability over time. And there's been some work in certain ecosystems pointing to reduce flammability as the forest ages over time. A lot of variability in this system, so we haven't seen that pattern. So a sort of in immediate years after fire, there's a reduction in that tall shrub cover, but as things progress over time, there's really not much change. So no sort of a lot of variability across the system. Just a bit of an overview of some of our fauna results. So we recorded 62 bird and 18 mammal species. And we recorded 44 at enough sites to be able to model, to be able to run them with our statistical models, which is pretty good. And to cut the long story short, very few species were actually affected by fire. So only 9% of species that we looked at had a detectable response to time since fire. So the rest of the species seemingly didn't care too much. And just to compare that to what we found in eastern Victoria, so in the Otways, out of 44 species, only 9% of species actually responded to time since fire, whereas in eastern Victoria, it was about 25%. And a very similar ratio when it comes to fire interval. So a lot more species are responding to fire in East Gippsland compared to the Otways. This could be for a number of reasons. I think probably the planned burn versus wildfire thing is one thing. Much more of a strong response when you're looking at wildfire, but also those systems are quite different as well. They're much taller than they are in the Otways, and there's different species over there as well. And just some examples of some of the responses that we did see among the few species that did respond to fire. So species like the long-nosed potoroo here. There's going to be quite a few talks I noticed about long-nosed potoroos in heathlands today. In the tall mixed forest, we did see that they are responding in a positive way to time since fire. So they're increasing as fire is further in the past. So yes, more common in mid-stage and older stage vegetation than in young vegetation. So I guess it's important that we have mid-stage and older stage vegetation and burning in such a way that retains unburned vegetation for the potoroos. Also, we found some responses to fire intervals. So the crescent honeyeater was mostly found in sites that had longer fire intervals, so longer times between the last couple of fires. And there was probably more species that we actually found a negative response to time since fire, so they preferred recently burnt vegetation. And these two species here I'm highlighting because we actually found this across 5 or 6 of the ecosystems that we've studied. We've found a consistent response among these species. So common brush-tailed possums and buff-rump thornbills, both preferring that recently burnt vegetation. With the common brush-tailed possum, we think this is probably because they're more likely to come and forage on the ground, potentially in recently burned vegetation, rather than their abundance being higher necessarily. So they're more likely to be picked up on camera. But buffer-rump thornbill, we've seen this quite consistently across the state now, that their abundance or occurrence is highest immediately after fire. So sort of filling that sort of post-fire niche. And hundreds of examples of species that didn't seem to care too much, so their abundance or their occurrence didn't really change with time since fire. So lots of species that are quite resilient to the different fire regimes across the Otways. So just in summary, the tall mixed forests of the Otways have got a really highly diverse faunal community. They provide habitat for a range of rare and threatened species. There's evidence that many species are resilient to planned burning regimes among the birds and mammals especially, but evidence that some species do prefer different stages post-fire, so that we need to be carefully managed for those. Lots of varying fire responses seen, so it highlights that species diversity is going to benefit from a range of patterns in fire across the landscape. And also fire responses are really different in different parts of the state and in different ecosystems. So this requires carefully tailoring management approaches to the local situation. That's it for me. Thanks very much.